Welcome to practice problems 1.6, representing sequences. Okay, an arithmetic sequence starts 2, 5. All right, so the first thing we do, when we see an arithmetic sequence, underline arithmetic sequence and write plus minus over it. Figure out your change. 2 to 5, I have to add 3 to get from 2 to 5. Okay, so now, recursive definition, formal recursive definitions are the same. You have your start term, a of 1 equals 2. A of any term in the sequence is the previous term, the change, and then the next term for n greater than or equal to 2. So the next term must be bigger than whatever your first term was. Remember, these are inputs. Okay, use your definition to make a table of values. So if n is our inputs, and we make an XY table vertically, n is the same as x, and a of n is the same as y, our inputs and outputs. All right, so we started at 1, was 2, 5, what am I doing? 2, step 2, or the second number in the sequence was 5. The third number, the fourth number, the fifth number, the sixth number. So if I just keep adding 3, plus 3 is 8, plus 3 is 11, plus 3 is 14, plus 3 is 17. So A of 6 equals 17. A geometric sequence starts 1, 3. So geometric, when we see the word geometric, what we're going to do is underline geometric sequence and write multiply and divide. We're in Algebra 2 now. We do not use an X for multiplication. We use a dot. So times 3. To get from 1 to 3, you have to multiply by 3. So now, our recursive definition, A of 1 equals 3. A of any term in the sequence equals the previous term. Oh, this is supposed to be a G. I'm sorry. This is supposed to be a G, people. The change for n greater than or equal to 2. Sketch a graph of the first 5 terms of G. So to sketch a graph, I'm going to need a table of values. So 1, 2, 3, 4, and 5, these 5 terms. Okay, so we got the first term was 1, the second term was 3, times 3 is 9, is 27, is 81. So now to sketch a graph of the first 3 terms. 1, 2, 3, 4, 5. 1 is real low. Then it goes to 3. Then it goes to 9. And then 27 and 81 is way up here. And we can see this graph is starting to curve. Geometric sequences make curved graph. Explain how to use the recursive definition to determine G of 30. Okay, so G of 30, using the definition above, equals G of 30 minus 1, which is the 29th term, times 3. Or you go from 81 and you keep multiplying 3. So if this is the 5th term, you get the 6th term multiplied by 3 and keep going until you get to 30. You could do it that way, whichever way you think. Okay, now to match definitions, we look at our first term and how we get from 3 to 5. We multiply by 5. 3 times 5 is 15. 15 times 5 is 75. So our change is times 5. And now we find a definition that matches times 5. And these are not formal definitions. These are partial definitions because they would give it away if they had to, sorry about that, if they had to list the first term because it would be too easy. The second one, Since we don't have our first term, the first thing we do is look at our change. So to go to 18 to 6, you divide by 3. To go from 6 to 2, you divide by 3 or multiply by 1/3. And as we can see, we got 1/3. That's the only one that's times 1/3. So for recursive sequence, if you have a sequence, look for the first term, look for the change. All right, 1 to 2. So you can add 1, but 2 plus 1 is 3, not 4. So if you times 2, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. That doesn't work. What if we plus n? So for step 1 is 1. If I plus n, step 2 is 2. 1 plus 2 is 3, minus 1 is 2. Okay, that works. 2 plus 3 is 5, minus 1 is 4. That works. 4 plus 4 is 8, minus 1 is 7. That works. So I think the next term is going to be sorry, I did this again. Is this one is going to match this one, and let's work our way through 17, 13, 9. Oh, so this is minus 4. So this is just minus 4. And this one matches that one. Okay, now let's look at this problem. Write the first 5 terms for each sequence. Okay, so the first term is 1. Oh, let me put this in pencil. The first term is 1 times 3 is 3 times 3 times 3 and then times 3. That's the first 5 terms. B is 1. We subtract 2. We get negative 1, negative 3, negative 5, negative 7. 1, 2, 3, 4, 5 terms. And then the next one is 1 times 2. 1, 2, 4, 8, 16. The next one is 1, the previous term squared, the output of the previous term squared plus 1. Okay, so 1 and then 2. 2 minus 1, the output of the first term is 1, squared is 1, plus 1 is 2. For term 3, 3 minus 1 is 2. The output of term 2 squared is 4. 4 plus 1 is 5. Man, this is weird. 4, term 4 is the output of term 3 squared. D3 is 5. 5 squared is 25 plus 1 is 26. Yes, and then 26 squared is a big number. 25 times 25 is 625. 26 times 26 is 625. I need a calculator. 26 times 26, 36, 12, 15, 12, 4, 5, 676 plus 1 is 677. Oh, they're giving us some goofy ones. So the first term is 1. 2n plus 2n minus 2. So D2 is the first term, 1 plus 2 times 2 minus 2. 4 minus 2 is 2, plus 1 is 3. All right, the output, term 3 is the output of term 2, which is 3, plus 2 times 3 minus 2. 6 minus 2 is 4. plus 3 is 7. Term 4 is the output of term 3, which is 7, plus 2 times 4 minus 2. 8 minus 2 is 6, so that gives us 13. So 1, 3, 7, 13. And then term 5 is the output of term 4, plus 2 times 5 minus 2. 8 plus 13 is 21. Wow, that was a weird one. All right, so we have to determine the next two terms. F of 1 is 120. F of 2 is 60. 120, 60. So 120, 60. How do we get there arithmetically? We divide minus 60. So determine the next two terms if it is an arithmetic sequence. So 0 and then negative 60. Then write a recursive definition. 120, f of n minus 1 plus negative 60. Negative 60. Okay, determine the next two terms if it's geometric. So to go from 120 to 60, we're dividing by 2. So 30 and then 15. So this is 1/2 times, and that's that one. Okay, after 1 hour, antibiotic is, bacterial population is 1 million. Each following hour decreases by half. Okay, so decrease by half is 500,000. Then 250K. K is 1,000. Then 125K. Then 62,500. And then 31,250. Do the bacterial population? Yes, because we got the same number divided or multiplied each time. So yes, and that's how you figure out your sequences.